guys. Hopefully everything's going well with you, making your way through all these different assignments. Today's section is similar triangles. Now, last section was similar polygons. You guys got some ideas how these work. In the similar triangles, there's a few specific things that we want to highlight. Now, the first one is a postulate, and the postulate is what's called the angle-angle similarity postulate. And what it says is if two angles of one triangle are congruent to two angles of a second triangle, those triangles are similar. Now remember, similarity doesn't mean they have to be the same size. Okay, but if the angles are all congruent, then it is based on the definition of similarity, the ratio is going to be such that it is a similar figure. Okay, so what you have to remember is if you know two of the angles, you know the third, and you could find this third angle here, and you could find this third angle here, and they would all be congruent. And that would show that since all of those angles are congruent, the whole thing is similar. And then you'd want to make sure you know the similarity statement. You guys saw that in the last section, but if I put something like ABC is similar to blank, A is congruent to F, so F would go first. Okay, G is congruent to B, so G would be second, and then H is congruent to C, so H would be third, and that would be your similarity statement. Okay, so in this first example, it asks us to determine whether or not they are congruent. Well, what they've given you is they've got the larger angle there. The larger angle is 137 degrees. We need to know, are these two things congruent given the other two angles? Well, right away, those two are congruent. That's awesome. Okay, well, 22 and 21 are not congruent. So what we've got to do is we've got to figure out what is that angle C. And remember that all triangles add up to 180 degrees. So if you take the 137 plus the 22, you get 159. Subtract that from 180, that gives you 21 degrees, which does match what we saw in the other triangle. Okay? Now, conversely, you could go through and do that same thing in this right-hand triangle, the FGH. Add those together, you're going to get 158, and that means that this angle right here is 22 degrees. Now, since all of our triangles, or rather all of our angles match, they're similar. So we could say that ABC is similar to, well, FGH, and that matches up. So that's how you can do it based on a couple of the angles that you're given. Now, a couple of the other things that we need to know are these two theorems. The first one is the side-side-side similarity. And it says if the corresponding side lengths of two triangles are proportional, then they are similar. Okay, so what this is telling you is you look at these sides of the triangle. As long as the sides of the triangle are similar, and we're talking all of the sides, as long as they are all proportional, then the triangles are similar. The second one is side angle side similarity. And this says if the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle and the included angle, those triangles are similar. Alright, so you've seen some side-side-side and some side-angle sides dealing with congruency, but now it's the same thing with similarity. As long as all of those ratios are the same, they are considered to be similar. Okay, so here's an example. I've got this figure here, and we want to know, are these things similar? Well, there's a couple different ways you can go about it, and so let's take a look. We can start by just seeing what we think. Now, based on the information we're given, I would say that AB and DE could be similar sides. Okay, so I'm going to set those up as a ratio, which would be 6/9. Okay, now we take that, we reduce that down, that's going to give you 2/3. Alright, so now we know that AB and DE have a ratio of 2/3. Alright, are there any others in this triangle that have 2/3? Well, how about DC and CB? We could set those up as 4/6, which reduces down again to 2/3. What that leaves now is CE and AC. Well, CE is 5, AC is 7.5. If you reduce that down, both those numbers have a common factor of 2.5. That reduces down to 2/3. Now, since all three of those are the same, those figures are similar. Okay, so what we need to do is now write that similarity statement. So I'm going to take and just put it as ABC. So ABC is congruent to what? Well, AB is here. That's the same as DE. Right? So DE is a logical thought so far. Okay, then I went from B to C, and that would go from D to C. Well, does that make sense? I don't know. Following around this triangle, it doesn't. So DE isn't the right place to start. We went instead from E to D, and then from D to C. All right, and then finally, we're going from C to A, and that's C to E, and that now matches everything up. And that works. And that is based on the side, side, side. All right, so there's an option for side, side, side. Now, another option which you guys may have picked up on kind of goes back to what we did earlier with some of these side, 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 or side angle, side. But look at those there. Those are directly across from each other, which means they're vertical angles. Okay, so you could bring an actual angle into this. Now, we already decided the 5 and the 7.5 have a common ratio. The 4 and the 6 have a common ratio. And so that gives us now the side, angle, side, or side, angle, side. And that is another way that you can prove that. Okay, so two options there. All right, let's look at another one, see what we can work through. It says, show why ABE is similar to ACD. Okay, now this is this smaller triangle here, ABE, and then the larger triangle, ACD. I want to know or show that those two are indeed similar. Well, how can we do that? Well, right away, they both share that angle. So there's an angle that we have in common. Okay? Now, these two triangles here mean parallel. Now, since we have parallel lines, they're cut by a transversal. So parallel line here, cut by a transversal. What does that tell you about these two angles? Well, if you remember, they're what are called corresponding angles. And corresponding angles are congruent. And so that makes those two congruent. Now, based on that, we could also say that these ones, here, here, and here, are congruent. And we now have three angles that are congruent. If we go back up to the very first thing from this section, we have that angle-angle similarity postulate. That is proof that those two triangles are indeed similar. Okay, so there you go. You prove that with the angle-angle. Now the second part is we need to find these. Find BE and AD. Alright, so let's think of what we got. Well, this whole side, AC is 5. AB is 3. Because of the segment addition postulate, we could say that BC is 2. What that now gives us is a full-on look at these different parts. Well, because this smaller triangle has that side of 3, and this bigger triangle has the side of 5, that's actually a ratio we can use. We know that those two are the same. So we could say that we can set that up as a ratio of 3 to 5. Right? Now, since we want to know why, we could say that that smaller side and this larger side are similar. Well, 3 was the smaller triangle, y is the smaller triangle, so we have to put those in the same position. Now the larger side, AD, is going to be whatever value we get for y plus whatever whatever value we get from y plus a 3. So we're going to say that's y plus 3. Alright, so we took this smaller side and this larger side over this smaller side and this larger side. And now it's a proportion. We cross multiply and solve. So 5 times y is 5y. Cross multiply here. 3 times y is 3y. 3 times 3 is 9. Don't forget you have to distribute and solve this out. So I'm going to subtract 3y from both sides. End up with 2y equals 9. Divide by 2 and y equals 9 halves. There's my first answer. Now for the second one, we want to figure out what x is. X is this length right here. Okay, it's similar to this length right here. So I can set that up as x over 3.5. Now remember, we use the ratio 3 to 5 from these two right here. It's going to be the same. So since x is the smaller triangle, 3 is the smaller triangle, and it sets up to look like that. And just like before, we're going to multiply. So you take 3.5 times 3, and that gives you 10.5. Okay, so cross multiply. Cross multiply here, you get 5x. Then divide by 5, and x is going to equal 2.1, and there you go. Alright, so that's how you can use these similar triangles to figure these out. Just find out what the corresponding sides are and go from there. Alright, on your own, I want you guys to see if you can do this one. Okay, so try and come up with an explanation. Why is RSW similar to RVT? And then find out what WR and RT are together. Alright, hopefully you guys took the time, pause the video, and let's see how you did. Well, right away, here's what we can do. We know that W is congruent to T based on the markings. We also know that R here is congruent to R here because of vertical angles. Now, our postulate from the beginning says if we have angle-angle similarity, those two figures are similar, so it's good. Alright, WS and VT are similar. So what that leads you to is a similarity statement of, the ratio of 8 to 10. Now, since 8 comes from this smaller triangle, the x plus 6 has to go on top. 2x plus 6 comes from the larger triangle with the 10, so that's going to go on the denominator. And then from here you just solve. So we're going to cross multiply. Okay, make sure you distribute. So 8 times 2x is 16x. 8 times 6 is 48. Go in the other direction, 10 times x is 10x. 10 times 6 is 60. And now you just solve. So we subtract 10x, subtract 48. You've got 6x equals 12. Divide by divide by 6, and that gives you x equals 2. Now, make sure you understand what they're asking for. They want WR and RT. They don't want x. So we take our 2 and substitute it here, substitute it here. So WR is x plus 6, or 2 plus 6, which is 8. Okay, RT is 2x plus 6, or when you substitute that in, 2 times 2 is 4, plus 6 is 10, and there you go. Alright, that's the way that we can use some of these properties in similar triangles. If you have questions, please contact me. Don't get too far behind, and if you need some extra help, I'm happy to be here. Otherwise, good luck on your assignment, and we'll see you soon.